Hello, my name is Charles Samuel. I am going to present to you assignment 4. I am part of CSC380. I'm part of the online section. Just so you know, I'm undergraduate and I have implemented the Markov model size picker, so that's good news. So let me talk about this a bit. So the way that my program runs is so right now we run it. You're going to ask a couple of questions. So, first question is the size of the model. So, let's do 4. There's some limitations on these, just so you notice. Must be greater than 2 is mainly because my implementation makes use of forces that at the beginning of each name is 2 underscores, and because the model is going to include those 2 underscores, it could run into issues when it starts. So, let's see that. Look up model size. Do you want a boy's or girl's name? So, boys, and minimum length of name must be greater than 1. Obviously, because the name is not going to be 1 character, maximum. Okay, and then we can pick a number, which is 5. So right here is Mellow, Friend Drew, L, our Junior, Monster. They're weird because they're novel, the patterns aren't always going to look nice. So, let me go into my model. So we have our main, which just simply makes use of my class. The entire thing makes use of this class called Markov model. One thing you're going to note is I have a name list and have an item called array middle. Array middle is a class that is the model itself, each with all the depths. Markov models, it's a class that the main uses to access all this information. So when you first build it, you give it an order, a size, and we'll create an order of that size. You load the list. Right now you have boys or girls names, and right now I automatically format it so you have 2 underscores in the beginning and end of each name that I pull off that list. And then we have translate name to Markov. And what I'm doing is say if you have Markov model 4, the idea that I represent that 4 layers, it's a 4 pattern. So if it was Aaron, it would be AAR, AAR. So each of those letters represents a layer within the Markov model. So what I do is I take each of those sections from 0 to 4, 0 to 5, 1 to 5, 2 to 5 until at the end of the word. I put them to the model to give me my sum and my probability. I have a class that creates padding, which allows me to append this just in case the string gets more string at the end. And then we have generate name, which does a lot of verifications, such as length, novelty, verification of the name pattern you currently have. So, right now, with the class that calls build name, what build name does is, say if you had a 3-layer model and you had an AAR. If you were going to search for the next word, what you would do is you give it AA. Say if you were doing a 3-layer model and you had to start, and you give it 2 underscores, it would search for the number after that model. So when you start off, it's going to keep building this pattern larger and larger until it gets to that model size, and since the model size, it's going to keep at that size and pull the number, the probability of that next number, keep updating the name. And then you have verify name. Just make sure the patterns that are in the name generally follow the patterns that are in the model. And then you have the novelty, which just checks the list of the names you pulled in and make sure that the names you generate are the same as those names. So this is the main working class. I like to call this a dynamically built array. And for the sake of time, we have a level. Step entry is 0, 1, 2, 3, whatever. We have a letter map, which is the letters in comparison to the next deck, and then you have count. And then you have the sum, which starts at 0. So when you first build this class, you call array middle, and then you have another constructor, which is private, which calls level. So the first function is add letter. And what add letter does is it goes through, you give it a string to say, like when I said AR for Aaron, and for a 3-layer model. What it does is at that level, it takes that character, it checks to see if it exists, and if it doesn't, it creates a new array model at the next step. and then it increases the count at the current depth, and then we call add letter on the next step in that string if there's more. Then we have add count, which just adds count to the current, adds count of that letter to this, and then we have get next letter. What next letter does, like I said, give a prefix. So if you were searching for Aaron, or say the word name is going to be Aaron, and you had AA, and you had AA, you would look for the next letter, which would probably be R, if you the end result was Aaron. And then we have valid string, which just checks to see if this pattern is proceeding along the line, and making sure if we can get the end result, we can pass back true. If we can, it's false. Thank you for your time. I hope you enjoy my assignment, and have a nice day.